Lesson 6 will be our introduction into inequalities, and we're going to focus first on solving inequalities by using addition and subtraction. So the good thing that we're going to find with inequalities is you're going to realize real quick it's almost exactly the same thing as solving equations. However, the big difference here is much like with expressions, our variables are going to have an infinite number of answers that could possibly make this true. However, there's also an infinite number of answers that will not make it true, which sounds crazy, but as we look through it, it'll start to make sense. All right, so let's get started down here. It says a first class stamp can be used for letters and packages weighing 13 ounces or less. Fisher is mailing pictures to his grandmother and only has a first class stamp. His envelope weighs 2 ounces. Find the steps to determine how much the picture can weigh so that Fisher can use the stamp. So step 1 says let X represent the weight of the pictures. Write and solve an equation to find the maximum weight of the pictures. Well, we'll start out there by looking at the weight of the envelope. It says his envelope weighs 2 ounces. So we know the envelope weighs 2 ounces. It says plus the weight of the pictures. Well, we don't know the weight of the pictures. So that's going to give us a value of X. And for the after the equal sign, to the right of the equal sign, we want the maximum weight of the package. All right, so we are going to find that the maximum weight for the package is 13 ounces. All right, since that's all you can use for that type of stamp. So the maximum weight of the pictures would come out to be, we would subtract 2 from both sides. That'll give us 11. So X equals 11 ounces. All right, so that's the most the pictures could possibly weigh. At most, you could have 11 ounces worth of pictures. All right, so what we're going to do is replace the equal sign in your equation with the less than or equal to symbol. So get rid of equals. We're going to substitute in less than or equal to. It says refer to step 2 and name 3 possible values of X that will result in a true sentence. So there are more values than just 13 that would make this true. All right, so for example, we could say that 5 would make that true. 2 plus 5 is 7. All right, and 7 is less than or equal to 13, so that's true. All right, how about the value of 1? We could say 2 plus 1 is 3. 3 is less than or equal to 13. So those would both make this a true statement. So this is how we can say we have multiple numbers that represent the value of X, which is a little bit different than when we were doing equations. So solving inequalities, it says you can solve inequalities by using the addition property of inequalities and the subtraction property of inequalities. When you add or subtract the same number from each side of an inequality, the inequality remains true. So this is just like the notion of balance in our equations. All right, anything you do to one side of an inequality, you must do to the other side to maintain that truthfulness behind it, or else it falls out of balance and the whole thing doesn't work anymore. So it says an inequality is a mathematical sentence that compares quantities. Solving an inequality means finding values for the variable that make the inequality true. The table below gives some examples of the words you might use when describing different inequalities. So this is the table you want to refer to when we have word problems and we need to construct our own inequality. So anytime you see less than or fewer than, you're probably going to use the less than symbol. Is greater than, is more than, exceeds, that means you're going to use the greater than symbol. So those are both indications where the value you're speaking about doesn't count in your number set. So for example, if you say it's less than 5, 5 is not a number that makes it true. Now, if we have is less than or equal to, is no more than, or is at most, that's a less than or equal to statement. And then is greater than or equal to, is no less than, or is at least, that would be a greater than or equal to statement. So let's solve some of these guys, and you're going to find them to be very familiar. So we've got x plus 3 is greater than 10. This is very simple. We're going to treat this exactly the same as we treated our equations. All right, we're going to isolate our variable. In this case, we'll subtract 3 from that side, leaving us with x is greater than, and then we'll subtract 3 from the other side, leaving us with 7. X is greater than 7. That's it. That's all we need to do. Now, sometimes they ask you to graph these. Graphing them is really easy too. We simply put our graph, put 0. We've got the number 7 here. Since it is greater than, we're going to do an open circle and shade in everything to the right. So that tells us that every value that is larger than 7 makes that a true statement. All right, next one, solve. Negative 6 is greater than or equal to n plus 5. All right, excuse me, n minus 5. Getting ahead of myself. Okay, to isolate our variable, add 5 to both sides. 0 plus 5. Negative 6 plus 5 is negative 1. So we end up with negative 1 is greater than or equal to n. Now, here's a little trick. If you like having your variable on the left, you can do that. But remember to switch your inequality. My inequality looks a little funky there, doesn't it? So note how the point of the inequality stays with the variable, which in this case is negative 1. All right, so to graph this one, again, pretty simple. The smartboard would agree with me today. So here's 0, here's negative 1. Now, since it's less than or equal to, we'll do a nice big closed circle. That means 1 is included in our number set, and then we fill in everything to the left because it's less than or equal to negative 1. And if you look down below, there's a couple of more practice problems. Why don't you hit pause now and take a minute and run through those, and I'll throw the answers up so you guys can see them. All right, for letter A, you find that A is less than 11. And for B, you find that Y is greater than or equal to 6.6. So there are your answers for those two. All right, for number 3, we've got a rational number in our inequality, and they're also asking us to graph it on a number line again. All right, so we've got A plus 1/2 less than 2. All right, so we want to isolate A, so I'm going to subtract 1/2, and then I'm going to subtract 1/2 here. 2 minus 1/2 gives me 1 and 1/2, so A is less than 1 and 1/2. So this tells me any value for A that is less than 1.5 makes this a true statement. So I'm going to start with 0, 1, 2. So here is 1.5. All right, open dot since it's just less than. All right, closed dots mean that the number is included, but 1/2 is not included. We want anything smaller than 1/2. So 1, 1.25, 0.5, any of that kind of stuff, that makes it true. So that's what our answer is going to look like there. All right, and then a couple more practice ones for you here. All right, again, hit pause, solve these, come back, and I'll show you the answers, okay? Go ahead, give them a shot. All right, so for letter C, we're going to have H is greater than 0. So this is an easy one to graph. We have 0, open circle, because H is not included. So everything larger than 0. So 0.0001, that would be true. But 0 itself, not so much. And for D, we have X is less than or equal to 10. So we could have 0, 5, 10. Since this one is less than or equal to, closed circle, because 10 is included in that group. 10 would make it true. And then everything smaller than 10 makes it true as well. All right, so when we actually have to write them as well, all right, that can be a little tricky, but not something that we can't do. It says inequalities can be used to represent real-world situations. You will want to first identify a variable to represent the unknown value, just like when we were solving equations. So number 4 says Dylan has $18 to ride go-karts and play games at the state fair. Suppose the go-karts cost $5.50. Write and solve an inequality to find the most he can spend on games. All right, so let's think this through. He has $18, right? He's got this $18. All right, we know the go-karts are already $5.50. He's already spent $5.50 on go-karts. So we can assume that this is gone because those are our go-karts. All right, the total amount of money he has is $18. What we don't know is how much can he spend on the games. So we'll let the red represent his games with the variable G. All right, so the go-karts plus the games have to be no more than $18, or at most $18. That means this amount could be equal to 18, or they could be less than 18, right? Because he could spend $17, that would be fine, because he's got 18 in his pocket, that'll cover it. But if he spends $19, if the cost of his go-karts and his game is $19, then he's out of luck, then he's going to be short, and he's going to get a grumpy go-kart manager on his case, all right? So let's go ahead and take a look at how we'd solve this. So we still want to isolate G. We want to get it all by itself. So let's start by subtracting the cost of the go-karts. That gives us 0. So we'll subtract that exact same amount over here. So $18 minus $5.50 comes out to be $12.50. So we find that the amount he can spend on games has to be less than or equal to $12.50. So he can spend $12.25 on games, he can spend $12, he could even spend all $12.50, but he can't spend $12.51. All right, so for tonight, you guys are going to do the guided practice here. We've only got 4 questions. 2 are solving for the variable and then graphing on the number line. Number 3, you're going to write your own inequality and solve it. And then number 4 says explain when you would use addition and when you would use subtraction to solve an inequality. So if you guys have any questions, save them for tomorrow and we'll talk about them. Thanks.